Hello, everyone. My name is Charlie. First and foremost, they had to artificially limit me and not give me speaker's notes, so that's why I have the iPad. Otherwise, I'm just too powerful. So I'm the web accessibility lead and developer at EasySurf. If we're going to get some slides. And I'm going to talk about accessibility. So before I get into that, a little bit about why you should even, I guess, listen to me. I became disabled at 18 with chronic regional pain syndrome, really fancy way of saying damaged nerve, which is why I have the cane just here, but he's going to pop away. At 21, there were some more medical complications, and I actually dropped out of studying finance here at QUT, and spent the next couple years just really trying to navigate some pretty complex medical and legal systems. And simultaneously, I learned how to code using Free Code Camp and other online resources. And then finally joined a boot camp here in Brisbane and got into the industry. So getting into web development weirdly wasn't a choice for me. It was what was available, what gave me financial freedom and that level of success. So getting into accessibility was a choice for me because it allowed me to do this for other people and help them get that financial freedom, access to that medical care, or even just watching the latest Netflix. There are these barriers kind of everywhere for so many different people, and it's actually quite exciting to be able to try and help fix those. So we'll figure out how this works. Are we getting any more? There we are. So I work for EasySurf. We are an international firm that helps not-for-profits, governments, and global brands make their tech work for disabled folk. What that means is things like screen readers that help blind people understand what's going on the screen. It's also things like voice control technologies and being able to interact via voice. It's also 100 other scenarios like being pregnant and being dizzy, or being in the sun and not being able to see a screen properly because of the glare. There are hundreds of different situations where a little bit of extra accessibility ends up helping everyone. So that's what I do at EasySurf. So before I get going, a little quick overwrap. We're going to talk today about what is accessibility, how does the browser know how to talk to assistive technologies, how can we improve that experience for screen readers, which we'll get a nice little video of, the common Laravel mistakes I see, how we can improve that experience for voice control, and are there any trade-offs, which, spoiler alert, not really. So the web at its core is a conversation between people and machines. As I said before, we have things like screen readers, voice control technologies, switch devices. This also includes things like search engine optimization. So every time someone visits a page, there's a dialogue happening between those humans and the machine. So the browser is speaking to technologies, assistive or otherwise. These are graphic rendering machines, screen readers, voice control systems. And they're all speaking the same language, the same love language, which is semantic HTML. So that's what they love to hear, that's what they want to listen to, that's what gets them confident and feeling secure in their relationship with the browser and the human is HTML. So just a little thought of what if HTML vanished. So for me, when I first asked this question, it was pretty hard to imagine straight off the bat. I can imagine my social life would be a lot more interesting. I'd have a lot more free time. But what is easy to imagine is if we remove the CSS that we use for styling. So thank you, Michael, for letting me ruin Laracon website just there. As we can see, once we remove the CSS and the JavaScript, we've actually got a website here that still makes a lot of sense. We can see where we're going. We can see what we're up to. And for the most part, outside of things being wildly the wrong size, all the information we need is actually there. But if we then remove the HTML, Literally nothing. That's our entire book. So there's no headings to navigate by, no buttons to press, no links to follow. You would start looking, have nothing to see, and in the same way a screen reader would start reading, and there's nothing there for it to interpret. And that's what happens when we start treating HTML markup like some decoration, and we start using these div tags everywhere instead of semantic HTML. So assistive technology really doesn't care about CSS or JavaScript, barely ever. Instead, HTML communicates everything. So it's got our meaning, our state, our order, and without HTML, that assistive technology has nothing to work with. So here is a very quick example. As I said, I spend most of my day looking at clients' products and seeing how they can actually function for disabled folk. What I get a lot of is things like this, where it looks really nice, really clean, really modern. It loaded really quick. It used Tailwind in a way that was actually beneficial. And there was definitely like a designer out there that was really, really proud that every pixel is where it should be. And at the same time, I think there was probably a developer out there that was pretty proud of how quick it loaded, how performant it was, and things like that. But when I sat down and tested it with a screen reader, absolutely none of this came through. So there's a main navigation region that was 24 different tab stops of just different links. Some of them were plain text, some of them were links. I had no idea why. It's because some were drop-down menus. And then when we get to this add new user, which is the most important function for what was an invoicing tool, there was no response whatsoever. So this is a div tag with a click handler on it. And we even have that little plus icon included in the name. So when we were navigating on screen reader, that just said add new user. There was no indication that it was a button or any functionality. When we try and access that with voice control, the name of that label is plus add new user. So whenever I said add new user, it couldn't find what it was looking for. So absolutely none of that comes through. And it's really a shame because we should be proud of the work that we're doing as developers and as designers. And when that doesn't get through to everyone, it's a big shame. And of course, this isn't about adding more code. Choosing a div tag and a click handler and adding all that it's hacky. We're using things we don't need to use. When we use that semantic HTML to begin with, we're not adding any more code. We just have a stronger base to start with. So where does it even come from? We've discussed that HTML is important. We've discussed that these standards exist. But where do they even come from? And this is a conversation I get a lot. As an accessibility specialist, I think a lot of developers think we're just some weird black hole silo work. But these standards come from public working groups across the globe. Anybody can join WCAG, which is your Web Content Accessibility Guidelines working groups, and contribute to these standards. Those standards are then added to HTML specifications through, again, a whole bunch of different working bodies across the globe. And then once they're in the HTML specifications, they then flow down to the browser, and finally everybody starts benefiting from that. So when we're discussing the idea that semantic HTML is important for accessibility, this, like everything, was not invented in a vacuum. Accessibility was one portion of why the decision was made. Things like performance, maintenance, and all the other things are also used for creating these HTML specifications. So what does that conversation actually look like? So some people will understand and have seen the document object model before, and that is this really complicated thing on the left that is meant to be complicated on purpose. Now ignore that. So the document object model is essentially the layer of structure that the browser and assistive technologies and automation tools like search engine crawlers and things like that are actually interacting with. And so the document object model, or the DOM, when we converse with that, he's a really good guy, and he's worth listening to. So every element that we write in HTML ends up being transferred across to that document object model, and that's rendered in the browser. So instead of using our div tags and div tags and div tags and div tags, we can use things like a header, and that tells the browser that this is the start of the page. And then we can use headings and add that structure in for what the content is. We can use things like a nav tag to highlight that it's navigation, and we can even have things like dialogue and summary components in later browsers that act as those automatic accordions and pop-ups that we're still achieving in a really hacky JavaScript state across a lot of the internet. So assistive technology doesn't see, again, your CSS. It doesn't see your colors or your fonts. It purely cares about this hierarchy of meaning that we see in our document object model. And so when that structure is really logical and semantic, we're getting a very confident conversation happening between us and DOM. But when it's missing or inconsistent, then that confidence instantly collapses, because the moment somebody on a screen reader encounters a component that they're not expecting or is marked up incorrectly, they're going to assume that the entire map is incorrect or the entire instructions are incorrect. If you've told them to look for the first floor and all they can see is signs for the second floor, that they're going to assume that the rest of the map is wrong as well. So before we look at some specific examples, I just want you to have a think around the idea that every user interacts with your website or application via the DOM, and most search engine optimization and robots are interacting with your website through the DOM as well. So some are doing that visually, some are doing it audibly, some by voice, some by keyboard, some have to rely on an iPad, but they're all doing it through a structure of the DOM if they're visiting your web page. So I want to show you two forms that look the exact same. One is using that div markup, and the other one is actually using semantic HTML. So we'll give this video a go.
Edit text, blank. Edit text, blank. Name required. Edit text.
So you'll see we actually ended up on the second form straight away there, because it can't even find the send button. So a screen reader user, they will get edit text blank, edit text blank. So I hope they know that you're asking for a name and an email, not an email and a password. Otherwise, they've just shown that to everyone. Simultaneously, for a voice control, if I say, let's access the name input, it has no idea what I'm talking about. It just sees two inputs. So when we go to the second example,
Name required. Edit text. Email required. Email. Send button.
so it's the exact same visually, and we haven't done anything fancy. We are literally just using an input element with a label and an actual button. So now we get the idea that it's a name, and we can edit the text in it, and it's required. And then the same with the second input as well, and of course we actually get a button that makes sense. So even though these two forms look the exact same, there's such a big difference in adding that HTML that really doesn't become clear until you are using assistive technology. So what does that actually look like? We just heard things being read out there. Where does that come from? We said that there's the document object model. What translation is happening there? So luckily, with modern browsers, we don't need to imagine what this communication looks like. I would always recommend that we learn how to use a screen reader and some voice control and go through and actually test our websites. But luckily, we don't even really need to do that anymore either. So we have a thing called the Accessibility Tree API, and this is available in every browser's developer tools. There will be a tab that says this, and this literally, as it says, API, it is a real API supported by all the browsers, and it maps everything to a name, a role, a value, and a state. And this is coming straight from your HTML tags. And whilst every browser and every screen reader, for example, may announce things differently. They all have their own quirks. Some of them have their own bugs. What we can infer is that it can never guess. So whilst we have our working one here with the form, the label, the text of name, and the input, maybe a screen reader will announce that as input name required. Some might announce it name input required. But a user will understand, and depending on the screen reader they're using, that's what they will expect. But when we have our original one on the left that just has the placeholders, then we're going to assume that we have to guess. So whilst we never know what the write will output exactly, we do and can always guarantee that we can't guess, so we need that information there. I will preface this with the idea that I have audited a few Laravel projects. I don't work in it. So at the same time, this goes across to any project that you're working on. If there is a front end, then these problems will appear, and we do want them to be fixed, hopefully. So the top 3 issues that we see at EasySurf in our Laravel projects is really, really small markup decisions that end up flowing through and having barriers across the board. So I've chosen these 3 not just because they're numerous in the issues we look at, but because they can be fixed really on a template level and across the board quite easily. So we'll walk through the 3 big ones. The first is the use of actual headings. So this is a web page. I've used a Chrome extension called Headings Map, which does a really great job of visualizing what your headings are on your web page. So when we look at this, it's really hard to see what this page is about. We seem to have 2 level 1 headings, the CSS and JS incident, the Ali Awakening. We have a chapter 2 there, we have a chapter 3, we have a chapter 4. I can't see a chapter 1. It's really confusing. And when this is on a web page like this, it's because we've decided the visual styling is more important than the semantic styling. We've decided that headings should be this size, and then the next set of headings should be slightly smaller, and it's all visual. We can apply semantic headings and then apply our own CSS. So we don't need to be doing that. So once we actually use semantic HTML, it's really, really easy to see what that page is about. And when people are navigating using a screen reader, this is primarily the view that they're going to navigate by. I want to, again, clarify that everybody uses assistive technologies in their own way, but most commonly I see people navigating by headings and trying to get a structure of that page. So now instantly we can see this is about someone's journey to becoming a senior developer. We can see chapter 1, 2, 3, and 4. And I personally would love to learn about that time I used tables for layout. So it's really easy to just jump straight into the content we're after. And that's what that looks like if we're just trying to create a reusable component. So as I said, we're not adding more code. It definitely looks like there's more code here, but all we're doing here is allowing for configuration to happen. So instead of chucking things down as a div, we're going to say from the get-go, headings are definitely going to be a heading. And now I have to declare what level that heading is as well. So every time we're adding a heading to a page, we're making a meaningful decision about where it sits in that hierarchy. The second one I see a lot of is links versus buttons versus divs versus all 3 at once. So for a link and a button, it often looks fine, but there are 100 little things happening under the hood that I don't think a lot of people realize. So for example, a link has a URL, and so if you're dragging that from a browser, the element, you can always drag that up to your URL bar and find out what the URL is that you're going to. Doesn't seem that useful until you need it. And then the idea that it's a link versus a button becomes really important because I want to know where I'm going. And so for a screen reader, again, when they're interacting with a button, and then suddenly they're on a completely different page, all of the context has changed, it can be a really confusing experience. And at the same time, when I click a link, I expect to end up on a different page. But if an action happens instead, and I feel like I haven't changed, but all the context around me has changed, I'm going to end up equally as confused. So this is more of a philosophical one than anything else, in the sense that do we use a link or a button? And we want to say really, really simply, if it navigates somewhere, use a link. If it does something, use a button. If it does neither of those, we can look at using a div, because that's just static text, or even better, a p tag or something similar. Cool. The last one we see a lot of is silent SVGs. So anybody that's been to an accessibility talk before will probably have had the lecture that we actually mark up images with alt text. We describe what is happening in images, and we should always do that. No, we shouldn't. We should only describe an image if it's important. So is it important to the content that's going on? Or very increasingly, is the image an instruction for a button? And that's when it becomes really, really clear that there are meaningful images and decorative images. So when we're talking about meaningful images like this magnifying glass here, I don't want to give it an alt text of magnifying glass because that's not what it means. What this means, amongst other UI, is probably something like search. And so that's the name I want to give it. Currently, when we use voice control and we try and click something, we need to know the accessible name of it to say, click this. And that means it needs to be fairly intuitive, or preferably rely on text, not an icon. But if we're going to rely on an icon, there are ways of doing it. So I'm going to show you another example here of what happens when, instead of just using a button with an SVG in it, we use a button with a labeled SVG in it, or we label that button and then hide it. I listened back to this video a lot. I'm sorry that you have to listen to me talk through this and through that, and thank you, I appreciate it.
Press search. Press search.
So that's me saying press search.
Search now.
That's what it told me to try.
Show grid. Press 11.
So all up, that took about 25 seconds. To be fair, about 12 seconds of that was me trying to use it correctly and then getting frustrated that it wasn't working correctly. Because the label names didn't work, I then showed a grid pattern and then could say press 11. That's only useful when your icon is the only thing dead center of the page. When you're looking at nav menus and navigation menus and things like that, you're going to say show 11, zoom 18, show 12, press 13, and you're finally going to get there. So that took 25 seconds. This is what happens when we do it properly.
Press search. Press
Oh, it's going again. Let's give this one a go.
Press search.
Done. So that's 2 seconds, which when we're talking about the idea of 2 versus 20 seconds, it doesn't sound like a lot. We've all probably got a spare 10 seconds if we're scrolling through a website. Now do that 100 times just to order your groceries. And it starts becoming a really, really slow and frustrating experience. So those are some of the examples. As I said, the last little bit of my talk would be, what are the trade-offs? And as I said, that's a trick question. When we're developing properly and we're caring about our HTML, there isn't much more effort that is specifically just for accessibility. So we've heard this a couple times already today. We've had Jordan with his legacy talk. We had Mish talking about the testing. And it's the idea that like when you start writing clean code that you can actually read, everything starts benefiting along the way. So as I said, what assistive technology you use to talk to your computer, that's the exact same thing that the search engine optimization crawlers are doing as well. They're relying on those semantic headings to understand the structure of your page, and they're relying on a good title. They want to know where the links go. Something like click here doesn't mean anything to Google. It wants to know why you put it on that page and gave it that context. So the SEO improvements are simultaneous. And then we end up with better performance as well. We get quicker loading times. We're not relying on JavaScript and extra files to do what HTML can already do in a really core performative way. And then better maintainability as well. As I showed with the headings, we now created a system where every time we put a heading on a page, it's a purposeful decision. That means there's no accidental headings. I know what needs to be cleaned up, and I know what everything does. And it's same with things like a button and a link. Like we obviously all hopefully use design systems, and hopefully accessibility can be a big part of that design system. And then when somebody goes to update a button, it's a button, not a div with 17 click handlers. And then you end up with HTML as your single source of truth as well. We don't have that horrible legacy idea before of using PHP to then insert JavaScript, and simultaneously, we're not using JavaScript to try and achieve things that HTML already can. So HTML is the single source of truth, whether you like it or not. That's what these accessibility APIs are drawing from. It's what SEO is drawing from. It's what browsers are drawing from. So you can either treat it as your single source of truth and actually go, do we need JavaScript for this? Do we need that extra bit of server compute for this? Or can we just use the HTML? Because it's going to happen like that anyway. So that's why I argue that accessibility isn't any extra work. It was work that you were probably avoiding doing anyway that had benefits elsewhere. And so every time we choose the right element, and every time we add a label or a heading, we're aligning that entire stack towards being semantic HTML. So again, the most accessible interface is the one that explains itself. When I was writing this talk, I was really worried that I'm literally just talking about HTML. I mentioned ARIA once, which is the lovely little bit of coding language made specifically for assistive technologies. The reason I didn't mention it is because, again, I don't think accessibility is extra work. I don't think it's one that's packed with ARIA attributes and extra scripts and extra instructions and all this hidden stuff. And at the same time, ARIA is powerful and necessary in some edge cases. But most of the time, if you're reaching for ARIA or you're reaching for a div tag or JavaScript, it's because you're failing to tell the story that you need in the markup that is available to you. So anytime we go to create a component or an element, let's work through that semantic HTML list first and say, why doesn't a button fit here? Why does a link not fit here? And once we can figure that out, once we understand why the fence exists, we can decide whether we tear it down or not. So we did go through a lot today, so I'm hoping here's some practical takeaways. We went through what accessibility is, why it matters, how to use a little screen reader and a voice control, how to fix these important issues up. So that's a lot. Top 3, respect that heading order. Like if we can give a page structure, then some of the other issues we can get away with. If all of the instructions make sense except for one little piece right near the end, then we can at least go through with confidence up until that point. At the same time, use real buttons and links. If we can tell a user what's going to happen before they do it, then they're going to get a lot less confused. Ensure our meaningful icons are explained, and at the same time, hide the icons that don't matter. Which is all to say, use semantic HTML. That is the entire point of the talk in one sentence. If you can, test with voice and a screen reader and a keyboard. I'm here for the next couple days and absolutely love to talk to anybody about how to do that. And the last checklist item is an anti-checklist item. Don't worry about ARIA yet. Don't even use it. You don't need it. Stick to HTML until you start having problems with that. And that is me. Thank you.
Excellent, look at that.
Zero.
The clock just hit 0. That's incredible.
Perfect.
Thank you
No
very
time for
much,
questions.
Charlie, for coming and talking about accessibility. Well, let's have a couple of quick questions. Is there any automated tooling testing that can be used to kind of measure an increase or decrease in accessibility?
Yeah, I guess firstly, 2 words, arseless chaps. There is a lot of tools out there that talk about 40%, 50%, 60% coverage. These are all really cool. Things like Wave and AxeCore are really good testing tools to have in your developer pipeline.
Yeah.
We should never be relying on just those. And the false positive nature of them kind of makes it a bit difficult sometimes as well. But as one small part of a larger testing tool, yeah, things like Wave and AxeCore.
Cool. Do you have like 1 or 2 websites that you would classify as like the most accessible that you look to for inspiration?
Yeah, I guess globally, mygov.uk is seen as a very, very good one. I guess a little bit of tooting my own horn. Telstra, who I used to work for, still has quite an accessible website considering how complicated it is.
Yeah.
And yeah, maybe the British are just doing something because the BBC as well. It's a very basic design, but the code is very clean.
Excellent. No worries. Thank you very much, Charlie.